second part of the session this afternoon. I would like to introduce Lucie and Malá, who teaches English at the Department of Language Education at the Faculty of Mathematics and Physics of Charles University. She is also a PhD student, and her topic of research is phraseology in mathematical research articles. And today she is going to talk about designing and developing subject-specific materials for students of mathematics. So,
thank you very much for the introduction. First of all, I'd like to thank those of you who are brave enough to come to a talk which contains the word mathematics in the title, and also say that this was not meant to be only for people who do something with mathematics, so do not worry. It's not really mathematics that much, it's more focused on the method itself, although the title is a little misleading. So, and it doesn't do anything. Ale mně nejde přepnout vůbec ten slide. A to přepnout, to právě to nejde.
Jo, tak daj mě prosím tě hlavně.
A už to jde, pardon. Už. Já jsem klikala dolů tam. OK.
Jestli se to streamuje, tak musíme asi anglicky, ale kdyby ne, tak tady všichni...
Já bych to radši asi řekla anglicky, kdyby vám to nevadilo. Protože já, když mám ty slidy anglicky, tak je to hrozně schizofrenní pro mě.
Já jsem si myslela, že to bylo ulehčení, ale...
Ne, já se omlouvám, ale já jsem řekla o tom tématu spíš mluvit anglicky, než neštěstí. Okay, anyway, so back to English, back to the talk. It's okay. So first of all, what the textbook challenge is. Okay, so I will try to explain why it might be challenging to find or use any kind of textbook for a specialized course like in English for mathematicians. Then I will offer my solution, and that is to use a corpus for developing teaching materials. And so I'll try to say what a corpus is, because I don't know how much familiar you are with corpora, and what kind of tools can be used to analyze it and how to get the materials from there. And I'll try to show what it can do for you or what you can do with it on 3 examples of corpus-based materials, and try to show that you can develop both deductive and inductive exercises from there. So, okay, so the challenge. All right, well, recent research has shown that there's staggering differences between the way that different disciplines use language. And so there's this need for disciplinary specificity, namely in education for discipline-specific foreign language courses, such as English for mathematicians. Now, for this course, logically, you need some kind of specialized textbook. An obvious solution that offers itself is to use and maybe adapt slightly some kind of English for academic purposes materials. Well, this is not so easy for mathematics. If you look at the most common topics discussed in English for academic purposes, let's see what happens. Well, hedging, for example, commonly taught. Well, mathematicians do not hedge. At least in their writing, you will simply not find hedging, or not to a degree where you would need to teach that. Passives, okay, another common topic, how to represent oneself in writing. Well, in mathematicians' papers, what you find is an incredible amount of active forms with we. So passives, no, we're not interested in teaching that. And to mention just one more, even the whole research paper structure differs, at least for pure mathematicians articles, from the predominant academic structure of the method, introduction, and so on. So the result of that is that English for academic purposes simply is not English for mathematicians, and those materials are cannot be conveniently used for the course. All right, so another solution would be an ideal solution. There would be an existing textbook specifically for English for mathematicians. I could just take that and use it. Splendid. Well, despite the number of textbooks which deal with, for example, English for law or English for medicine, the number of textbooks for English for mathematicians is extremely low. You can think about why that is on your own. Okay, those that do exist are fairly outdated. And I'm not talking about your textbook. I'm leaving that aside for some reasons. I'm sorry. So outdated. The newest ones around the year 2000, so that's 20 years ago. Even if you admit that perhaps the language has not changed that much in mathematics, these tend to be style guides, focused on how to describe formulae, perhaps, or how to set numbers in the texts, and not really on the language itself. And in general, there is a lack of exercises in the textbooks. So what to do about this? My solution of this problem would be to turn to use of a corpus. I don't know how many of you, can you just raise your hands if you have ever used a corpus? Oh, cool. So all of you are corpus users. I can do this very fast then. Okay, so a corpus, all right, a collection of naturally occurring texts, fine. Now, in the context of creating teaching materials, two possible uses that I see in here would be one as a source of examples, the other one as source of some kind of information. And I will try to show what I mean by this on the examples when we get to them. No matter how you use them, the corpus, you have to be very much aware of what it contains and therefore what kind of conclusions you can draw from that. So that's the issue of representativeness. A corpus is usually designed to represent a variety of language. In our case, perhaps it could be the English of some mathematicians. But what you cannot do is, for example, to have a corpus of mathematical research papers and based on that draw some conclusions about, let's say, what mathematicians say in lectures, right? Because that's simply not what the corpus contains, and one should always be aware of that. Now, where to get a corpus, how to get your hands on one? Well, you can use available corpora, and you as experienced users of corpora will probably know how to get them. So there is just a note of listenglishcorpora.org where you can find a list of available corpora, or you can access a huge number of corpora through Sketch Engine, which is one of the tools that you can use for exploring your corpus. Or in the case that such a corpus that you would need does not exist, which can easily happen with mathematical English, you should not be afraid of creating your own corpus. And I think people are overly afraid of creating their own corpora. But I believe that as long as you do not skip the point of be aware of what it contains and what conclusions you can draw, as long as you always have this at the back of your mind, there is no danger in actually creating your own corpus. How to do that would be a completely different talk, and I don't have time for that. So this, because of mathematics being so underrepresented in linguistic research in general, I'm using my own corpus. It's a corpus of mathematical research papers. It's Komar. And this is where the examples in this presentation are taken from. Okay, now once you have a corpus, what you will need is, of course, a corpus analysis tool. That's some kind of tool that will help you to browse through your corpus and look sort of inside it. So luckily there's a number of freely available software you probably are aware of, AntConc tools by Lawrence Anthony, or Lanxbox developed in Lancaster with beautiful graphics. I hugely recommend that. Or what you can do is use some tools that you need a license for. Universities currently, our universities have the license for Sketch Engine, for example, which is very user-friendly. And it will be also used in this presentation. While these tools offer various functions, such as word lists, collocations, n-grams, and what have you, in this presentation, what I will try to show you is what you can do with the simplest possible tool, and that is the concordancing tool. That is looking at a word in context, so the so-called keyword in context. And what you can see in here is that the keyword we're looking at is the word theorem. As the left context, that's the right context, and also you'll get some kind of information on the frequency of the word within your corpus. It's usually the case that what you can do is somehow sort and filter the individual lines for the keyword, and that's all that we will need. All right, so let's move on to the examples themselves. And we'll start, the first one we'll start with on the deductive part of the scale of all possible exercises that you can create. So in this case, it will be aimed at practicing a simple rule. I want my students to practice the rule that in mathematics, it sometimes happens that mysteriously, even with countable nouns, there is no article. So it's with numbered items, mathematical disciplines, characteristics of an object with width and half. This is the rule. Okay, in this case, I will use the corpus simply as a source of examples, nothing more. So what can I do? Well, I can think of a number of items that would exhibit this unusual behavior, such as number theory in here, type that in my corpus, do the simple search, and from the results that you can see over here, simply choose the most representative or easily accessible for my students, or those that I like, depending on how you want to choose that. Now, from these, it's not difficult to compile an exercise, which would be one of those classical deductive exercises, such as this one, where I ask my students to study the rules and then cross out all extra articles from these 5 sentences. So what I've done simply is just taken out of the corpus examples of instances where this happens, then do the violent thing and add the extra articles, and my students can then work this out. All right, so that was using the corpus just as a source of examples, and the result was a deductive exercise. Okay. Now with the second example, I'll try to show you what I mean by using the corpus as a source of information. The initial question in here is, how is the universal quantifier represented or expressed in words in mathematics? Well, the direct translation from Czech and also my students' intuitive guesses would be for all, for every. All right. So I have this intuitive guess, but I'm not really sure. So what can I do? Well, I can ask my corpus. So what I can do is search for the expression with a wildcard. That's the little asterisk over there. So search for something to see what is happening in those texts. And not surprisingly, you will get a lot of irrelevant hits, right? Like for computer, for example, for subsequent, and so on. But at this moment, one does not need to panic as long as we remember that this is something that will be probably represented in the texts a lot, so it will be very frequent. So a little trick that can be applied is looking at the frequency breakdown. That means looking at which of those quick forms are the most frequently appearing ones in my corpus. And that will give us perhaps some better idea of which ones could be the universal quantifier. So the ones suspicious of that, well, perhaps some more as well, could be for all, for any, for each, and for every. Now, of course, this little thing down here, look at the individual concordance lines. Well, one can never be satisfied with just looking at the frequency breakdown and assuming that for any automatically will be a universal quantifier in the text. One has to always go back to the instances in the text and verify if that is indeed the case or not. So gaining this knowledge can, of course, then result in a kind of exercise, which you can see somewhere in the middle between deductive and inductive, where I ask my students to complete examples drawn from the corpus with for all, for each, for every, for any. And so this is where it's deductive, because you tell them the answers, basically. They just need to put them in somehow. But what it does to students is that it provokes their thinking about it. And they immediately go for the simplest way and ask, okay, can't I just put for all in all of those? Do I really need to know for each, for every? Why should I be worried about that? And that's where it can become inductive, in that you can ask your students, okay, well, what do you think? Look at the sentences. And because you have authentic sentences from texts that they're trying to be able to compose, they can figure out the differences on their own. At this point, of course, going back to corpus as a source of information, if I don't know the answer to those questions, what I can do is try to look back into the data and try to see on my own what is happening there and why it is that I cannot use for all in all of these instances. Okay. And last example, okay, would be constructing purely, let's say, inductive kind of exercise. It's targeted at the so-called presentative let form, which is a formulaic construction, let be in this case, we'll narrow it down to something even more specific, let variable be a noun phrase. And so a very non-prototypical example of that would be let G be a group. So how to search for examples of that? You can do a very simple search of just let and try to filter out lines that contain B. That would be very simple. Or perhaps you're familiar with using the Corpus query language, which allows you to formulate your Corpus queries in a more specific and detailed way. So what you can do on the first line, what I'm doing there is just looking for let, and then within there is a gap of 1 to 5 words, and then the word be. Or what I can do is make it even more complex and then say, okay, and after a gap of 0 to 4 words, there will be something that's been tagged as a noun. What one should know is that the more complex you make your search, the more risk there is of, unfortunately, excluding some of the things that you are actually interested in. So, for example, in here, I'm actually undergoing this danger that the corpus has been tagged wrong and something that has not been tagged as a noun. Also, if there are more words intervening, I will not get that, and so on. So it's not always the best choice to make a very complex query. So just as an illustration, I did a more simpler one. You can see that you get some things that you're not really interested in, but you can simply not look at them and look at only those that you're interested in. Okay, and the result of that, what I like to do with my students is to give them something that looks very similar to what you get as an outcome of the corpus search. So you will see something that is basically the keyword in context, that's the very yellow empty column in the middle. So that's where the keyword in context belongs. And then there's the left context and the right context of those. Well, for let, there's not much left context because I didn't want to give them that context, but you can decide how much you want to give them or not. So the first task is a very simple one, and that is to guess what the keyword in context is in here. So what completes all of these lines to make them meaningful. And then they will not have troubles guessing it's let. And then the real work, of course, comes. And what I ask my students to do is to look at all of these sentences and think about what they have in common. So how would you describe the pattern, its form? And we can try to draw that in sort of boxes or other means that are available to them. I'm not forcing them to use linguistic terminology at all. So how would you describe what can go in this box, what can go in that box, and so on? So in this case, it will lead to the focus on the difference between singular and plural, if that changes the phrase or not. And of course, hidden agenda in here again, the articles. So they will notice what kind of articles can there be on the right-hand side. What does it depend on? And they can answer all of these questions simply by looking at the sentences that you gave them. Same thing or similar thing is done for the meaning or function of those sentences. So asking about why you would use that in mathematical texts, possibly how you would translate that, where in the text it is it in the sentences, where is it at the beginning, at the end, where in paragraphs, where in respect to larger sections of texts. So all of these questions can be answered by your students simply by doing this. And in case it happens to you that you do not know the answer again in here, because so far we have used this more or less as sorts of examples again, but there's nothing that prevents you from going back again to the corpus and trying to see for yourself what the answer to those questions is. So a simple search for capitalized versus non-capitalized let, for example, will give you the answer to the fact whether let appears at the beginning of sentences or not. Okay, maybe I was really fast because that's were all of these examples that I had for you. So hopefully what I managed to show you is that a corpus can be used to supplement teaching materials for specialized courses, especially when there are none. You can use both available corpora, but I think one must not be afraid of using your own corpus, especially if it's only for example purposes. Okay, you can use it both as source of examples and you can ask it sort of to give you the information that you lack. And the advantages that I see in this is that's purely usage-based, means you select the target language that you want your students or that your students want to acquire. You give them relevant examples from that. It's a naturally occurring language, and it can directly correspond to your students' needs. Okay, thank you. And that's all. Let's do some references.
Okay. So thank you very much for an inspiring talk. So are there any questions from the audience? Is there anything you would like to ask? No? No questions?
Okay, so you have your own corpus?
Yeah, I do.
Yeah, okay, so where did you find the sources, or how do you search for
The relevant
high
sources.
quality sources?
High quality. Okay, so you might have noticed it's a corpus of mathematical research papers, and this one actually has been carefully designed, and it contains only published mathematical research papers. So these come from certain journals which are international, have international recognition. They're peer reviewed from the latest issues, yeah, these would be, they're also selected based on some topics, certain topics to correspond to my students' fields. So that's where.
Is it easy for you to sort out those that were only written by native speakers?
That's actually an interesting question. Thank you for that. I don't believe in this division of native and non-native. I actually agree with Graves and other researchers that there are no native speakers of academic English. And so there's no point in drawing the line between native and non-native when you're looking at the research papers, especially since there's actually no way of telling. And we can sort of take the fact that the paper has been published as a guarantee of the level of English, because otherwise it would not get published.
Yeah, because I did research into the discourse of economics, and I had to be very careful about this native and non-native, because I wanted to study the real native speakers' economic discourse features, and it's very difficult to find the information. It's like investigating into the origin of the author, and it takes time. So, but what's interesting is that, for instance, texts of Czech mathematicians, they contain a lot of, I don't want to say mistakes, but a lot of Czech influences in the language. So I think it is important if one really wants to find out what a real language in mathematics, in the native speakers area is. Yeah, but it's very difficult.
Yeah, the thing with this corpus, or this particular, the aim of that is that what it's trying to represent is what gets published. So the question of the real discourse, or which one is the real or true or authentic one, is, well, it's this one. Because I need my students to be able to write something that will get published. So therefore, if this got published, no matter who the original speaker was or where he came from, then this is it. This is the target language. So that's what I apply as criteria.
it depends on what the goal of the research is.
Yeah, yeah.
But what's interesting, I cooperated with some Czech mathematicians,
Hmm.
and they, if they are not sure, they open Google and they find examples from Google. And usually those are international examples and not real English, which is a lot of lexical problems and such things. So it's very unnatural. But they reduplicate the mistakes. Yeah? So all the unnatural features.
Perhaps that's why I think it's much better to sort of ask a corpus or look into a corpus for your answers, rather than Googling your answers. And you probably are aware of the fact that there's general English corpora, not only specialized. So whenever I am not sure, that's where I would go, not Google, because like you say, you can find a lot of strange
Google is the worst corpus manager.
Yeah, that can be difficult. Thank you.
At the same time, if I may say something, at the same time, there is another tendency during the years. The situation a little bit has changed because in communication with our colleagues from Mathis, professors of physics and mathematics, they told me that if maybe 15 years ago in editorials of various academic journals, they never were non-native speakers. Nowadays, there are more and more non-native speakers, and English is more and more shared by international community. So it is nowadays, I think, more and more difficult to say what is native speaker and what is, or who is native speaker and who is not native speaker. Is of course I formulate this in a little bit extremal way, but I was told this. So it also has some influence. So, but if these sources are really published by some prestigious publishing houses, and so it should be some kind of guarantee.
I think so.
Methods or the language used by these publications should be some way normative.
Perhaps I don't know if it's a question or a comment, or it's.
Okay.
I'm familiar with Sketch Engine, and I have been for years toying with the idea of using it. I teach clinical English, and I've never used it. And the reason I've never used it is that if I do medicine, I just can't create corpus called medicine because it's such a broad area. It would have to be cardiology, it would have to be pulmonary medicine, and so on. So my question to you is whether mathematics is a sufficient common denominator, or whether you have to go through some specialties. Because in medicine, I wouldn't be able to do that.
Okay,
probably.
Well, thank you for that. This is a thing. Of course, you can go indefinitely down, right? So, you can make it indefinitely more specific. Okay. So you can say, of course, in mathematics there's plenty of disciplines, and of course, each of those disciplines will have its own ways and strategies of doing things. But this corpus is constructed to sort of reflect something that they might have in common, and contains selected articles balanced from 3 different subfields of mathematics, which have been chosen based on the programs of the target group of students. So what I'm trying to do with that corpus is look at what all of these fields that my students are studying might have in common, and then look at that and try to teach them that. Because when you start worrying about algebra versus set theory, what you will end up with is an incredible closeness, or I don't know, just fragmentation. Yeah, fragmentation. Thank you. That's the word for that. Fragmentation. Yeah.
But then, what you also have to be working with is the students' motivation, because they are probably going to be going for something very, very, very specific. So that's, I mean, I don't know if it's an answer or a comment, but it's going through my mind. It's this, how specific the corpus should be for a group of students.
And do you believe that there is no common denominator to these?
I'm sure there is a common denominator, but the question is whether you want to teach those common denominators, whether you want to teach like the most frequent chunks, like on the basis of, or or whether you want to say, oh, this is academic English, and that's okay. It's highly represented in any academic text, and this is where the real mathematics start. So, I mean, it's a fascinating thing. I'm impressed by a presentation. It's certainly one of the best which I've seen at this conference. But it's the question of specificity for a specific group of students. That's what's
troubling.
What's troubling me. Yeah, and I can imagine doing such a course, or not doing such a course, but using this as a supplementary material. For example, for students who would like to write in publish articles in cardiology or in pulmonary medicine. So maybe I'm wrong.
I don't think you're wrong.
Maybe if I put anything which has medicine on it, and I would look at disciplines, maybe I will get interesting results, and maybe I will get discipline-specific results even when I have this relatively, broad corpus, which is something I don't know.
I think actually I don't. Have you tried to look at research into the phraseology of medicine?
I haven't,
because that's one of the disciplines that tends to be investigated quite a lot. So I think you could find actually some interesting insights already being done.
Okay, sure. That's. I would like from my personal experience, practice, I would consider this. Because we only have 2 semesters of English for everybody, but if I were to teach a specialist course just for dentists, just for pulmonary medicine, just for cardiology, I would certainly be taking the route which you have taken.
I think it's just a question of what you decide on, and of course I could go more specific, or could go more general. But like you said that you don't know if this is the question of English for academic purposes or English for mathematicians. I don't draw the dividing line anywhere. I don't care. What I care about is teaching something that's relevant for my students.
Okay,
so
that's fair enough.
I just decided to look at roughly at the fields that they might be working in and somehow see what they have in common.
Right.
And that's
even if it's on the basis of.
Exactly.
You don't care.
Yeah, I don't care. Yeah. Even if it were like on the contrary. Well, fine. Okay, lovely.
Yeah.
Yeah.
Sure. Yeah. That's good. It's good. What I also would love to do in the future is like for students to have their own corpora, and if they ask me questions, like do the same as you said. Look it up. Do your own search. So I think that's a fantastic approach.
Yeah. Okay. Thank you.
Okay. So if there are no more comments or questions,
I think that the discourse of mathematics is much more coherent over disciplines.
Could be the case. Yeah.
Especially in comparison with humanities, definitely, they are very loose, but also in comparison with medicine, so I think that there won't be so much incoherence.
I have not compared them, so I cannot say. It's a hypothesis.
Because I also taught for some years English for mathematicians, though I am not a mathematician. I realized that they differ, especially in terminology. Mathematical discipline, like algebra. But I think the structure of sentences is not so different in forms used.
I sort of do tend to see like differences, for example, in frequencies, right? Because I'm actually using the corpus for a more in-depth study of the phraseology of the text, which was the part of the PhD study, not only for teaching. But there tend to be differences, like for example, this universal quantifier would be more likely used by people from algebra than people from, what was the other one, mathematical analysis, for example. So they would have differences, for example, in the frequency of use of certain phrases. That might be the case. So there will be. But I think whenever you compare two things, you will always find some differences. So that's, I don't know. It's like the danger of that. Yeah, I don't know.
Okay, no more comments, so fine. So I think we can continue in this interesting discussion during the conference dinner. So Lucie, thank you again.
Thank you.